Hello guys, in today's class we shall discuss how to calculate various parameters of equivalent circuit. And this equivalent circuit we have discussed in the earlier class. Now based on this we shall calculate the parameters. Okay, let us see what are the circuit parameters. Okay, you know this is a stator circuit, this is excitation circuit, and this is your rotor circuit, and this is your load. Okay, so first I'm going to consider case 1, that is on no load condition. Okay, so on no load condition, above equivalent circuit can be rewritten as okay, this R1 X1 shall remain same, I0 shall remain same, ICM as well as R0 X0. But here what I can do here is, whatever we have series R2 as well as R2 into bracket 1 minus S by S will get reduced to R2 by S. How is that? Already we have discussed in your earlier class. I shall show you. Yes guys, you can see here, this is the rotor circuit. Okay, see, X2 R2 RL, that is R2 into bracket 1 minus S by S. Again, equivalent to this circuit, we have studied 3 equivalent circuits, right, in yesterday's class. So that can be, this can be again rewritten as like this, yes or not? X2 as well as R2 by S. This is what we have done here, yes or not? And anyhow stator circuit is untouched, it remains same. So see what I have done here. On no load, slip is very small, yes or not? Because slip will be around in terms of very less. Okay, like it will be almost equal to synchronous speed itself, your induction motor. So if slip is very small, if anything you divide by small thing, what happened? You will get the total value will be more. Okay, the total value will, whatever you, if you divide by smaller thing, the value will gets increased. That is R2 by S ratio will get increased. So that's what happens here. If that it gets increased, then what happens? R2 by S will be very much greater than the X2. Okay, R2 by S will be very much greater than X2. So what I am going to do is, if that is greater, means since X2 will be very less, as per this concern during no load condition, what happens? R2 by S will be very much greater, and X2 the reactance, rotor reactance will be what? Will be less. So what I can do here is, I can ignore that X2. Okay, see, I have ignored the X2 in the above diagram. So above diagram, after ignoring X2, you can see that it will be like almost short circuited, that is X2, because as I said it is very small, its effect will be also very small during no load condition. So I'm going to ignore this, I'm going to short directly R2 by S. Okay, now you can see that this circuit, this excitation circuit as well as R2 by S is what? Parallel in nature. So what I will do is, I will just do take R0 as well as R2 by S as parallel parameters. Anyhow X1 is also parallel, but initially let me finish this. Okay, so after doing parallel, applying the parallel resistance formula, what happens? Let me give, after doing the parallel thing, that is R0 parallel R2 by S, let us say I am going to get certain value. I am going to call that certain value as RIWF. What is that RIWF mean? RIWF is nothing but what? The resistance which causes iron loss, windage loss as well as friction loss. Okay, it's nothing but what? I have done parallel of R0 as well as R2 by S, and after doing parallel, what happens? I'm going to get certain value, yes or not? So that value I'm going to call it as RIW. Okay, RIW is equal to R0 parallel R2 by S. So R0 parallel R2 by S, I'm going to replace it by RIWF. Okay, it is called as rotational loss. So this is the thing which causes a rotational loss. Rotational loss includes iron loss, windage loss as well as friction loss. So finally what remains here? X0 remains C. Okay, now what I can say here is, again what happens, your RIWF usually during no load condition, what happens? It will be pretty much greater than the X0, and they are parallel. Okay, yes or not? They are parallel anyhow, and it is RIWF is greater than X0. So what happens? Again, if you apply parallel formula to this, okay, again if you apply parallel formula, then what happens? The resultant value will be closer to X0. Why it is closer to X0? First, you can take example of anything. Say this value as 1 ohm. Okay, let us consider this value as 1 ohm. X0 is equal to 1 ohm, whereas RIWF value is 2 ohm. Okay, So if you do 1 ohm parallel 2 ohm, then what will be the result? It will be 2 by 3. Yes or not? 2 by 3 is around how much? 0.67, right? 2 by 3 value is 0.67, and again 0.67 value is closer to 1 ohm, or whether it is closer to 2 ohm, it is closer to 1 ohm, right? So remember, whatever, if we do parallel between two values, and if one value is lesser, if value is greater, then what happens? The resultant value will be always closer to the small value, that is x naught. Okay, anyhow by default what happens? RIWF is greater than x naught. So if I do applying the parallel formula and all, what happens? I'm going to get certain value, and that value will be equal to x naught. Okay, it will be equal to x naught. So what happens here? So the above whatever circuit diagram is here, it again reduces to what? This. Again I'm going to ignore this RIWF, doing parallel of this and this. So what happens? Finally R1 X1 X0 will come into picture. Okay, so that's why I've written here the resultant value will be closer to X0. Okay, now no load reactance as viewed from the stator, means I'm going to view from the stator, and how it looks? XNL. XNL means no load reactance is equal to X1 plus X0. Okay, X1 plus X0. And what about no load impedance? No load impedance will be what? Equal to no load reactance plus resistance R1. Okay, plus R1. And again, how we are going to calculate ZNL? One more formula we have. ZNL is equal to what? V0 by I0. Okay, directly you can apply, because anyhow I0 will flow here. This V1 will become what? V0, right? And I0 will be same. So if I do V0 by I0 means I'll be going to get what? ZNL. And coming to no load losses, W0. So very simple formula, that is, it is basically an I square R formula, but we have three phases, so that's why I multiplied 3 over here. So it will be 3 into I0 square into RNL. Okay, 3 into I0 square into RNL. So finally, how to calculate RNL and all? RNL is equal to same W0 by 3 I0 square. Okay, you can ignore this formula, just can go with this as well as this, as well as the box formulas. Okay, anyhow we have way to calculate ZNL, we have way to calculate RNL, and if I know ZNL and RNL, we can easily calculate XNL. Okay, now XNL is equal to, again we know that ZNL square is equal to XNL square plus RNL square, but since I need XNL, so I can do it this fashion, that XNL is equal to square root of ZNL square minus RNL square, where W0 is the no load power input, which you know, yes or not. So by this method what we calculated is, we calculated no load reactance, no load impedance, no load resistance, as well as we also calculate the no load power input. Okay, by having the values of this I0 as well as RNL, we can easily calculate the W0. Okay, otherwise you can connect a wattmeter over there. Here just directly reads your no load input. Okay, now coming to this rotational losses, it is also called as PR. Rotational losses is equal to what? It is equal to W0 minus stator copper loss. Okay, it is very simple to understand. We know that W0 is the no load power input. Again, if I subtract stator copper loss, then what happens? If I subtract the stator copper loss, I will be getting what? Rotational losses. What is rotational losses? Rotational losses is iron loss, friction loss, as well as the windage loss. If I subtract stator copper loss from W0, I would be getting what? Rotational loss. It includes iron loss, windage loss, as well as friction loss. So that's why it is written here, PR is equal to W0 minus 3 I0 square R1. Anyhow, we know that stator copper loss is characterized by the formula I square into R. So again 3 phases, so it is 3 I0 square R1. So I0 means it is a no load current. Okay, R1 is the rotor resistance, which we know. Okay, again R1 can be calculated by applying a small amount of DC voltage to the stator winding and seeing the current flowing through it. Okay, I'm just dividing again what V by I, you will be getting what? R and all. Okay, that's a different case, just remember. Okay, next one is short circuit. First case was no load, second one is what? Short circuit. So we know that short circuit means what? Motor is not running at all. Yes or not? If motor is not running means what will be the value of slip? The value of slip will be equal to 1. So the equivalent circuit can be drawn as. So how the equivalent circuit will be? Again I shall show you the first one, main equivalent circuit. What I said slip is equal to 1. So slip is equal to 1 means what happens? See, to this circuit 1 minus 1 will be 0. So this whole particular part will be 0. So what happens? Only R2 and X2 will be in the circuit and this will be become 0. Okay, so this circuit, this whatever parameter is there, it will become to 0. Just R2 and X2 will be connected in the rotor circuit. So what I have written here, R2 as well as X2 is connected here. Yes or not? You can see. Okay. Otherwise, instead of considering this formula, I can go with this also. You can consider this also, where slip value is equal to 1. So X2 and R2 will be in the series. Okay. Instead of this, you can do in this fashion also. Okay. Better you consider this. Anyhow, I have written a variable load condition here. So the same thing is drawn here. So better consider that itself. So S value is equal to 1. So R2 by 1 is equal to R2 itself. So whatever we have with respect to this, it will be like this. Okay. One thing you can see from this short circuit condition, R0 is missing over here. Yes or not? R0 was there initially, if I am not wrong. See, R0 is present here for no load condition, but why it is removed for short circuit condition? Answer lies here itself, because we know that during short circuit condition we are applying a reduced amount of voltage. Due to the application of reduced amount of voltage, what happens? The whatever IC flows in the R0 will be what? Very less. Okay, so that's why the reason the drop will be also less. That's why the reason what happens? I'm going to ignore the R0. Okay, only X0 value is to be considered, because this is pronounced more when compared to that of R0. So that's why the loss due to IC is less. So I'm ignoring R0. So it becomes open circuit. So only X0 will come into picture. Okay. See, it's all everything approximate. Okay. It's not like 100% correct. Okay. It's all approximation. Now we can see from here what I can do here is, we know that R2 and X2 are in series, and R2 and X2 series, and both are in parallel with X0, right? So that's why I can see R2 plus JX2 parallel with X0, right? So again, after doing the value, what happens? I'm going to get impedance over here. Again, that will be in series with this, right? You can see that is why R1 plus JX1, R1 plus JX1 plus R2 plus JX2, these are in series. I am parallel with this. Okay, remember JX1 is parallel with only this component. Okay, it's not parallel with this. The space we shall reduce from here to here, from right to left. Hope this you have learnt in your NA classes and all. Okay, Rm plus Jxm. So this whole thing, whatever resistance and reactance are there, it is called as what? Equivalent impedance when referred to primary. That is stator. That is, so that's why it is called as Z1E. So Z1 is what? R1 plus Jx1 plus into bracket R2 plus Jx2 parallel with Jx0. Okay. Now we shall solve this. I shall keep R1 plus Jx1 as it is here, plus plus. Okay. Next bracket, we know that parallel formula is what? R2 plus Jx2 into Jx0 divided by R2 plus Jx2 plus Jx0. This is the formula, yes or not? Now I'm going to what? Rationalize. Now I'm going to rationalize the thing. Before that, first what I have done is I have multiplied here. Otherwise you can keep it multiply later. You can multiply now also. It's your wish. Now multiplied, you can see R2 into Jx0 will be R2 Jx0 plus plus. So x2 x0. So j square means minus 1. So plus into minus, it become minus here. And any of this thing is same over here. R2 plus j, taken j common here, x2 plus x0. I'm going to do rationalize this. Okay. Rationalize the reason which helps to separate real parts as well as imaginary part. Okay. So the rationalize means plus j becomes minus j here. Same thing written here. And I'm going to multiply again this. Okay. Anyhow, first we shall see the bottom one. It is in the format of what? A plus b and a minus b. So a plus b, a minus b formula is what? A square minus b square. So r2 square plus x2 plus x0 square. Instead of minus, I have written it as plus. The reason is what? j square becomes minus 1, so plus into minus into minus plus it becomes